about pulsars, and these pulsars are fascinating celestial objects that were first discovered in 1967 by astronomers Jocelyn Bell Burnell and Anthony Havish. They are a type of highly magnetized rotating neutron stars. A remnant left behind star after a massive star undergoes a supernova explosion. Pulsars emit regular pulses of electromagnetic radiations, often in the form of radioactive radio waves and occasionally visible light. Now, these pulsars, to understand these pulsars, we first need to know about the neutron stars. Neutron stars are incredibly dense remnants of massive stars that have undergone a supernova. When such a star exhausts its nuclear fuel and its core collapses under its own gravity, the protons and electrons merge to form neutrons due to the extreme pressure and temperature. As a result, neutron stars are incredibly dense with masses greater than that of Sun, squeezed in a sphere only about 10 to 20 kilometers in diameter. Now, how these pulsars are formed during a supernova explosion? The outer layers of the massive stars are ejected into space, while its core collapses to form neutron stars. If this neutron star has a strong magnetic field and is rotating, it can give rise to a pulsar. Now, I'm talking about the magnetic energy and its kinetic energy. As the original star collapses, its rotation speeds up due to the conservation of angular momentum. Now, this results in a rapid rotation rate of the neutron stars. Additionally, any original magnetic field of the star gets intensely amplified and it's compressed into a small volume of a neutron star. Now, this process can create magnetic fields billions of times stronger than that of Earth. And what are the emissions from these pulsars? The powerful magnetic fields of pulsar is not aligned with its rotational axis. This misalignment causes the emission of radiation from the magnetic poles to create a cone-like patterns. As the neutron star rotates, these cones of radiation sweeps across the space much like lighthouse beams. Only when one of these cones of the radiation points towards Earth can be detected. We detect the pulsar signal. This is why we observe a series of regular pulses from pulsars. Now, from observation and characteristics point of view, these pulsars emit pulses across various wavelengths, including radio waves, X rays, gamma rays, and their periods, the time between the two consecutive pulses, can range from milliseconds to several seconds. The shortest period known is around 1.2 to 1.4 milliseconds. These pulsars are very precise clocks. Pulsars are incredibly precise cosmic clocks. They maintain their rotation periods with remarkable stability over millions of years. This precision makes them useful for various scientific studies and including testing theories of gravity and searching for gravitational waves. From applications and significance point of view, these pulsar systems, especially binary pulsars in an orbit with another star, have been used to test Einstein's theory of general relativity. The observed orbital changes can be compared with the predictions from general relativity, thus providing important tests for the theory. Uh, Another important parameter is the gravitational waves. These pulsars can be the part of gravitational wave detection systems. As gravitational waves pass through our region of space, they slightly alter the arrival time of the pulsar's pulses. This can be used to detect the study not only detect but as well study the gravitational waves. And from navigation point of view, these pulsars have been suggested as a potential navigation beacons, for interstellar travel, as their period signals can be used for orientation in space. To conclude this video, these pulsars are incredibly dense and highly magnetized neutron stars that emit regular pulses of radiation due to their rapid rotation and misaligned magnetic field. Okay, so these cosmic lighthouses have provided valuable information into the fundamental concepts of physics, gravitational waves, and potential applications in space exploration.